titanium dioxide has a good properties, which is non-toxicity, long-term photostability, and high effectiveness. Besides that, titanium dioxide has a good mechanical resistance and stability in acidic and oxidative environment. These properties will make the titanium dioxide a prime candidate for heterogeneous catalysts. Therefore, there are several factors in determining important properties in the performance of titanium dioxide for application, such as particle size, crystallinity, and morphology. In this journal, titanium dioxide nanoparticle catalyst was synthesized via the sol gel method by titanium tetrahydroproposite as a starting material. Calcined at the different temperature, which is 400, 500, 600 and 700 degrees Celsius. The titanium dioxide was characterized by XRD, BET, FISM, TEM, TGA and UVVs. We can see the observation of the thermal degradation behavior. There is no weight loss on TGA after 400 degrees Celsius that indicate the composition of titanium dioxide precursor has completed. For the XRD, we can see that the particle size increased dramatically when the phase transformation from anatase to tau. The third characterized for the morphology, we can conclude that an increase of particle size with calcination temperature was increased from 400 to 600 degrees Celsius. So for the UVVs analysis, we can see that as the calcination temperature increase, the band gap gradually decreased. And at the high calcine temperature, which is 600 degrees Celsius, the band gap was at the lowest value, which is 3.0 electron volt, because the rutile phase and the size of particles become bigger. Synthesis of titanium dioxide nanoparticle at the calcine 600 degrees Celsius as show a good properties, and we can conclude that it is the good catalyst.
The presence of chlorinated compounds in aquatic environments has caused several environmental pollution problems. 2-chlorophenol and 2,4-dichlorophenol, a typical phenolic substance, has been used as an intermediate in making insecticide, herbicide, preservative, antiseptic. 2,4,6-trichlorophenol is particularly of environmental interest owing to its mutagenicity and carcinogenicity. Traditional wastewater treatment techniques consist of activated carbon adsorption and biological digestion. Each of these techniques has limitation and disadvantage. For activated carbon adsorption only involve the phase transfer of pollutants without decomposition, thus introduce another pollution problem. On the other hand, in biological treatment, the decomposition of many chlorinated phenols have proven inefficient, since chlorinated phenols are resistant to biodegradation within an acceptable time period and tend to accumulate in sediments. Chlorophenols do not undergo direct sunlight photolysis in natural environments, since they only absorb light below 290 nanometer. Therefore, the advanced oxidation process, or AOP, appears to be a good method
the light. So you can see there actually the HV is actually the sunlight. Okay, photon, titanium dioxide with the photon, then it will form the electron and H positive photon. Okay, positive hole, and then when it react with the water, it will split hydroxyl ion and hydrogen ion. So if the oxygen actually attached to the titanium dioxide electron, then it will form superoxide. So catalytic oxidation reaction initiated when photon of higher level or equal to the band gap energy is absorbed by the titanium dioxide, catalyst promoting an electron from valence band to conduction band. With simultaneous generation of positive hole H plus. So the photocatalytic degradation, actually they will calculate using this equation, CO minus CO over CO. Okay, actually CO is the initial concentration and C is the concentration of the 2-chlorophenol at the interval of irradiation time. The COD test will carry out according to to determine the chemical oxygen demand. If you see from the diagram, the effect of radiation and dark condition with absence and presence of titanium dioxide nanoparticle, 2-chlorophenol solution of 50 mg per liter as the initial concentration was selected for the calcination temperature. Actually it's high at the 500 degree. Calcination temperature of titanium dioxide sample was assigned as an important parameter effect on the performance of titanium dioxide for chlorophenol degradation. The optimal loading to achieve the best degradation is 200 mg per liter, and this concentration was tested with different initial concentration of phenol.